Hello and welcome to your channel AWS Cloud Bytes. I'm your host Bhavesh Kumar. Today's topic is AWS VPC Endpoints Explained. We are going to talk about saving cost and boosting security. So let's dig in. Okay, this picture is about the private subnet data flow with NAT Gateway. Now I'm gonna talk about why this is required and how it is expensive when compared to other ways of transferring data or talking to AWS services. So in this picture, you can see that you have a private subnet. This is the private subnet. And then we have this as a public subnet. In that private subnet, we have an EC2 instance, and then we have an AWS Lambda. Both of them, if they have to talk to an external service, it can be an Amazon S3, it can be a DynamoDB, or if it is a patch that has to be pulled for some of the softwares that are running on EC2, it will be again like some internet. Now, in case if it is an Amazon S3 or Amazon DynamoDB, it still has to go through this route because private subnet is not having internet access. Your public subnet is the only subnet that is connected over here to the internet gateway. So you have a NAT gateway in the middle. Any request that is required to go to the internet will go through the NAT gateway, which is expensive. And then the internet gateway is going through, this is the public internet. So the internet gateway will route through various hops in the public internet to reach to S3 or to the DynamoDB. The pros are it is in this scenario, at least to go to the internet, you have an outbound connection using the public internet, but it is going through a secure channel in this case because your private subnet is not having any direct connectivity to the internet. And it is a simplistic approach because you have the NAT gateway, a single NAT gateway for all the outbound needs in your internal subnets. So the private subnets, if they need anything from the internet and they make a call, this is the channel it takes. It always goes through the NAT gateway. Now the cons of this particular setup is that you have a NAT gateway hourly charge. So you pay for NAT gateway itself, and then you pay for all the amount that you transfer. So the two type of data charges that are, one is the data processing. It is charged based on the amount of data that is in gigs. So you are looking at the amount of GB data that is processed through the NAT gateway. And if the volume is too high, you're going to have a significant bill. The second is the amount of data that is transferred is also charged if the data is leaving AWS network. So in this case, it is going to the public network and then coming back to the AWS network when it is going to the S3 over here or DynamoDB over here. Now, when you're sending this data through public internet, even though it is going through secure channel, you have HTTPS, but still it is leaving the AWS network and going through the multiple hops of public internet until it reaches to the IP address of S3, which means the security is there, but it is at a higher risk. The last con is around the single point of failure within AZ. Even though the NAT gateway is a managed service and it is going to be scaled by AWS as per the requirement or as per the load that happens, it is possible that you have a single point of failure in case something happens to the NAT gateway, and it can be a bottleneck if it is not properly scaled. If there are multi-AZ and you're just using a single NAT gateway transferring data from one AZ to another AZ, if you're multi-AZ and you're still using a single NAT gateway, you will incur data transfer fees between AZs. If the data set is flowing from one AZ to another AZ, which means the data is flowing from AZ A to AZ B and using the NAT gateway of that AZ B to go to the internet gateway. The best case scenario will be like if you have two AZs, you will have to have two different NAT gateways, in each catering to their own AZs, which means you have two AZs to pay and you will be billed for two AZs, and two AZs will have their own data transfer fees and data processing fees. But at least you're gonna save inter-AZ transfer cost if there is any. I believe it used to be. I'm not sure if it is still there or not. Okay, how to solve that issue? So this slide is going to talk about first solution, and it is just one option. There is another option. So this option has been there for a long time now. This is like private subnet data flowing using gateway endpoint. Now what a gateway endpoint is, gateway endpoint doesn't need a NAT gateway or even a internet gateway. So you can see that your private subnet data, which is here, you have your private subnet, and you have two resources running in this private subnet. You have EC2 and Lambda. Both of them are sending data to the VPC gateway endpoint. Remember, this is a gateway endpoint. And there are two implementations, which means there is a gateway endpoint for S3 and there is a gateway endpoint for DynamoDB. I believe in the longer run, they may not be there or may be replaced by the other kind of endpoints, which is interface endpoint. But these were the initial implementations. So what are the pros of having this? First of all, it is cost effective because there is no hourly charge and there is no data processing fees. It's a major cost saving. Second, it is enhanced security because your data that is flowing from here to here is not leaving AWS network. Similarly, data flowing from here to DynamoDB is not leaving AWS backbone network. So the enhanced security is there. It is cost effective. It is enhanced security. It is simple because you just need to configure some route tables to provide the route from your private subnet resources to the S3. Now, what is the cons? First con is about the service. It was initially implemented, so I believe the implementation was done for these two services, the S3 and DynamoDB. Later on, the interface implementation, the interface endpoint implementation was widely successful. So you now have even a interface endpoint for Amazon S3. The second con is around regional specificity. And you can see that if you're using S3 in DynamoDB, it is only available or it can only be used within the same region as your VPC and endpoint is available. You cannot do cross-region access or like multi-region access. The last con over here is around private access. So there is no private IP address access because there is no provision of having an ENI in this case. It is more about route table targets. And we can talk about ENI in the next slide. The way it is configured in the route table, it will be more about a target where the data, if it has to go to S3, the target is a VPC gateway endpoint and which goes to S3 prefix, which behind the scene is a collection of IP addresses maintained by AWS. So you just send it to the prefix, and from the prefix, which is a list of IP addresses where the S3 is hosted, it is taking the optimal route for you. Let's go to the next slide. This slide talks about the other type of implementation. The first one that we looked at was around gateway endpoint. Now this is interface endpoint. And this is widely accepted. I would say there are many more services supported by this interface endpoint. And how does it work? You have a private subnet over here. Exactly same setup, EC2, Lambda. But you see there is an additional thing over here, and you can see the name is ENI. ENI is basically Elastic Network Interface. It's a network card, you can say, and it provides you a private IP address in this particular subnet. And it acts as a entry point for the VPC endpoint over here. Now, VPC endpoint is powered by private link. You can see AWS private links over here. And using this ENI in your private subnet, this VPC interface endpoint connectivity to Amazon S3, DynamoDB, and many more services. VPC interface endpoint is powered by private link over here. What are the pros of this particular setup? There is a broad service support. As I already mentioned, there are many services supported by this. You can talk to EC2 APIs. You can talk to SQS, SNS, Kinesis, CloudWatch, and many more that are hosted by AWS or AWS customers. Enhanced security, the traffic stays entirely within the AWS private network, which means it runs on AWS backbone network. Provisioning of ENI over here with private IP addresses in your subnet allows your application to contact the service endpoints using private IPs. So that's another simplification when communicating with external APIs. Simplified network architecture, it eliminates the need of a NAT gateway, internet gateway for supporting devices. All these services can be supported, similar to what gateway interface endpoint was doing. The only thing it wasn't doing was introducing an ENI, which allowed you to just use your internal or private IP addresses while communicating with Amazon S3. What are the cons of this setup? The cons are when you set up a VPC interface endpoint, you pay an hourly charge. The rate is however lower than the NAT gateway and significantly lower than that, but there is a charge. There is an hourly charge. And then you have data processing charge again, but it is significantly low as compared to the expenses around NAT gateway. If you look at the cost side of it, it is more expensive than gateway endpoints for sure to connect to Amazon S3 and DynamoDB using this setup, but it is way cheaper than the NAT gateway. And for some high volume, it is recommended that if the gateway endpoints are available, you can use gateway endpoint for free. And if it is somehow in the longer run, if it is deprecated, you will have to use this flow. The second con is similar to what we had in gateway endpoint, is that it is again region specific. You can see that it works in the same region. Cross region will incur charges. The last con is around management of these ENIs and your DNS resolution. With all these kind of ENIs introduced, because if you are talking to, say, 20 different AWS services and maybe 10 different AWS customer services, you will have a lot more ENIs. And these ENIs, when it is growing, it will be a thing to manage. So it increases your management cost. This is the end of the episode. Please like, share, subscribe, and press the notification bell icon for future updates. I'm your host Bhavesh Kumar signing off. Thank you.